Good day, everyone. Our topic for today is electricity and magnetism. So, at the end of this lecture, you shall be able to do the following. First, discuss the roles of the following: Franklin, Coulomb, Tesla, Faraday, and Ørsted. We are going to describe the nature of the electric field. Then, we are going to discuss the list of the laws of electrostatics. We will describe the nature of magnetism. We will distinguish between magnetic susceptibility and magnetic permeability, examine the role of electromagnetism in magnetic resonance imaging or MRI. So we know that both electric and magnetic fields and electromagnetic radiation are used in magnetic resonance imaging or MRI. Electricity is used to produce the primary static magnetic field, or BO, secondary gradient magnetic fields, which are the BX, BY, and BZ. A modest understanding of the fundamental physical concepts of electricity and magnetism is necessary for an understanding of magnetic resonance imaging. But before we dwell to discussing our topic for today, we shall review about the atomic structure. So the structure of an atom, we know that atom is the smallest component of an element. Its main parts are the electron shells and the nucleus. It consists of three basic particles, which are the protons, electrons, and neutrons. The protons are positively charged particles, the electrons are negatively charged, and neutrons are neutral or doesn't have a charge. Okay, we are gonna tackle the difference between the three, the atomic number, and the atomic mass. So the atomic mass number is the sum of the number of protons and the number of neutrons in an atom. So it is usually located the upper left of the chemical symbol, and the atomic number is the atomic mass number is located at the bottom of the chemical symbol, and the atomic number is located at the upper left side of the chemical symbol. The atomic number is the number of protons in an atom. Meanwhile, the atomic mass is the average mass of an atom. So let's start with electrostatics. So electrostatics deals with stationary electric charges. So the smallest unit of electric charge is contained in the electron, and it is negative. And the proton likewise contains 1 unit of positive electric charge. The mass of the proton is approximately 1,840 times the mass of the electron. Protons are relatively fixed by virtue of their position in the nucleus of an atom, whereas electrons are free to migrate from atom to atom under some circumstances. So in 1750s, it was Benjamin Franklin who first described the nature of electric charge, and his experiments have been popularly associated with flying kites. Funny as it is, but it is indeed true. Nevertheless, Franklin erroneously assumed that positive charges were migrating down his kite string, and Franklin called this migration of charge electricity. So it all started with Benjamin Franklin. And Franklin is also credited with much of the current terminology dealing with electricity, which are charge, discharge, battery, shock, positive, negative, plus, and minus. And in 1890, J.J. Thomson identified the electron as the fundamental charged particle responsible for electricity. Coulomb, or the coulomb, is the unit of electric charge. One coulomb is equivalent to 6.24 times 10 to the power of 18 electrons, while one electron is equivalent to 1.6 times 10 to the power of negative 19 coulomb. Lightning is lightning associated with thunderstorm has an approximate electric charge of 10 to 50 coulombs. Electrification. Electrification um, so the material is said to be electrified when electrons are added to or removed from the material. Electrification can occur by contact, friction, or induction. So electrification by contact occurs when an object having an excess number of electrons contains or contacts a neutrally charged object or an object with a deficiency of electrons. So that. So meanwhile, rubbing a balloon over your hair, make it stick to the wall, is an example of electrification by friction, so by rubbing. The loosely bound electrons of hair are mechanically transferred so that the balloon becomes electrified. Lastly, induction refers to the transfer of mass or energy between objects without actual contact between the objects. So the electric field. A force field called the electric field is associated with each charge. So the proof of electric field is much the same as that of a gravitational field, or the exertion of force. The electric field is a vector quantity, that is, it has not only magnitude but also direction. It has vectors. The direction of the electric field is determined by the movement of a positive charge in the electric field. In the presence of an electron, the positive charge is attracted, and therefore the imaginary lines of the electric field are directed toward the electron. And if in an electric field, the lines of force begin on positive charges and end on negative charges. So we have here a formula. E is equivalent to F over Q, where Q is the electric field intensity, which has a unit of Newton per coulomb. F is for the force on the charge, as a unit of Newton, and Q stands for the electric charge, and it has a unit of coulomb. Now let's discuss the electrostatic laws. So there are four principal laws of electrostatics. The first law is unlike versus like charges. So because of the vector nature of the electric field, as we discussed a while ago, like electric charges repel and unlike electric charges attract. So like charges, positive to positive, they repel, negative to negative, they also repel, while positive and negative attracts. So particles having no electric charge, such as the neutron, are not influenced by an electric field because neutrons are neutral, or it doesn't have an electric charge. The second law of electrostatics is the Coulomb's law. So the force of attraction or repulsion between electrostatic charges was first described by Charles Coulomb in 1780s. Charge distribution. Because the electric field associated with each electron radiates uniformly, electrons on an electrified object tend to be separated uniformly and the maximum dimensions possible. So free electrons are distributed on the surface of the object, not inside it. Okay? Take note, the free electrons are distributed on the surface of the object and not inside it. The last law of electrostatics is the charge concentration. So if the electrified object is regularly shaped, such as a sphere or wire, the distribution of electrons on the surface will be uniform. On the other hand, if the surface or if the surface is irregularly shaped, for example, it has a point as in an electrified cattle prod or a microfocus field emission X-ray tube, electrons will be concentrated at the sharpest region of curvature. So it will be concentrated on the sharpest region of curvature if it's regularly shaped. Electric potential energy. So the formula for electric potential energy are the following. E is equivalent to QV, W is equivalent to QV, V is equivalent to W over Q, where E is the potential energy, which has a unit of joule. Q is equivalent to the electric charge as a unit of coulomb. V is the potential and the electric potential, I mean, electric potential in volt, and W is the work in the unit of joule. Electrodynamics. Electrodynamics involves what is commonly called an electric current or electricity. Electricity deals with the flow of electrons in a conductor, and the science of electric charge and motion is electrodynamics. Electric current. So there are two basic types of current, the direct current and the alternating current. So it is direct current if the energy source propels electrons in only one direction. As with an automobile battery, the form of electricity is direct current or DC. At time zero, when the switch is open, no current flows. So the instant the switch is closed, electrons flow, but only in one direction. Or if the switch, ang meaning ng the switch is closed if closed ang circuit. So the current is flowing, but it only flows in one direction. The second is alternating current. So if the energy source is of an alternating form, alternating current or AC is produced. So when the switch is open, there is no current that flows, but when the switch is closed, electrons first flow in one direction and then reverse direction and flow in opposite direction. So the flow of electric charge that alternating current refers to the flow of electric charge that periodically reverses direction. Now let's discuss single phase current and three-phase current. So this illustration, the first one, this is a single phase. So this illustrates the current waveform. So at any instant, all electrons are moving in the same direction with the same velocity, and they are said to be in phase. So when there's a single phase, one wave only, and it is in phase. And the electricity is commonly called single phase current. So single phase current. So the second is the three-phase current. So at any instant, not all electrons are moving in the same direction and have different velocities. So we have kaya siya tinawag na three-phase is because we have three waveforms and they are out of phase of one another. So as you can see, ito, one wave lang. Here we have three. And the concept of phase is important to understanding of the way an MR image is produced. So yan lang ang main difference nila. Single phase isang waveform lang. Ang three phase is tatlong waveform. And yun, in phase and out phase. So now let's discuss the Ohm's law. So the Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. The formula for, we have a formula here. So here's a triangle. So here's V is for voltage, I is for current, and R is for resistance. So resistance has a unit of ohm or ohms, and the electric potential has a unit of volts. The electric current has a unit of ampere. So if you're gonna look for the voltage, we're just going to multiply the current and the resistance. If we are going to look for the current or the I, we're gonna divide the voltage and the resistance. So V divided by R. And if we're going to look for the resistance, we're just going to use the formula R is equivalent to V over I. So, yan lang siya. So, para madaling ma-recall. Okay. So, actually, electrons do not flow unimpeded in a circuit. So, hindi sila nag-flow na free-flowing lang. So, they behave much like an individual walking along a crowded sidewalk, bumping into people. So, electrons bump into other electrons of the conductor. So, this property of any electric device is called impedance. So, and this electric impedance is a function of the size, shape, and composition of the conductor or circuit element. So electric impedance, again, is a property of any electric device. It is a function of the size. And basically, there are three types of electric impedances. So capacitive, inductive, and resistive. So materials used in electric circuits are sometimes classified by their resistance. So we have four electrical states of matter. We have insulator, semiconductor, conductor, and superconductor. So when you say conductors, such as copper, aluminum, and seawater. So meaning madali lang silang madaanan ng kuryente, mababa ang kanilang resistance. The insulators are those materials with high resistance, such as quartz, rubber, and glass. So, mataas ang resistance. So, basically, hindi sila ganun kadali malatayan ng kuryente. And semiconductors are some materials that lie between conductors and insulators, such as silicon, selenium, and germanium. These are semiconductor materials that are used extensively in fabricating diodes, radiation detectors, and all types of computer chips. And the superconductor are those materials with electric resistance of zero. However, to behave as a superconductor, such as niobium do, a material must be, in addition lang nitong superconductor, wala siyang resistance as in zero, but it has to meet the extremely cold or cryogenic environment. So yun ang kanyang requirements. So now let's talk about electric power. Electric power is the amount of energy transmitted or converted per unit time. So it has a unit of joules per second or watt or watts, but watt or W is the unit of electric power. Now let's talk about magnetism. So like mass and charge, magnetism is a fundamental property of matter. So actually there are almost the same sa concept ng electricity, but somehow there's a slight difference. Now, all matter exhibit magnetic properties to some degree. So lahat ng matter, they have a little or a lot of magnetic property. So, yan. So, we've already discussed that the earliest magnets were described 2000 years ago as naturally occurring black stones that attracted iron. So, those are known as the lodestones, and they were thought to be magic by the natives in the region of present-day Western Turkey, and it was then known as magnesia in the Greek language, and the term magnetism was adopted from the city of Magnesia, and until now it still persists. Still using the word magnetism. So let's discuss magnetic domain. So a magnetic domain is a region within a magnetic material in which the magnetization is in a uniform direction. So this means that the individual magnetic moments, itong mga arrow, of the atoms are aligned with one another and they point in the same direction. Yan. So if this magnetic moments or these arrows point, most of them point in one direction, most likely it is magnetized. But if it's randomly pointed, hindi sila nag-point sa isang direction, well then it is unmagnetized. So again, most materials have their magnetic domains randomly oriented, so like this, and therefore exhibit no magnetism. So some materials, however, have their magnetic domains aligned and therefore become magnets. This is a magnet already. So the strength and number of magnetic domains naman in materials are associated with the material's electron configuration. So as we will discuss later on, an electric charge in motion creates a magnetic field. So in the case of common magnetic materials and electromagnetism, the magnetism is related to moving electrons, while in the case of a nuclei, the magnetism is related to the much weaker magnetic properties of the spinning electrically positive nucleus. So, ito siya. Atoms with even numbers of electrons in shells exhibit little magnetism. Kung even daw ang number ng electrons, like 222, or yes, they exhibit little magnetism. And atoms with unpaired electrons produce a strong magnetic domains, or it could be a strong magnet. And atoms with nearly half-filled shells have the strongest magnetism because electrons generally will not begin pairing spins until a shell is half full. Now, electron configuration determines three types of magnetism. So, ito pala ang nag-determine ng types of magnetism. So, there are basically three magnetic states of matter: the ferromagnetism, paramagnetism, and diamagnetism. So, um, ferromagnetic materials, so this first one, ferromagnetic materials have a magnetic susceptibility of greater than 1. By the way, magnetic susceptibility is or refers to the degree to which a material can be magnetized in an external magnetic field. So when you say magnetic susceptibility, the degree to which a material can be magnetized. So gaano katindi ba ma-magnetize ang isang material sa external magnetic field. So again, ferromagnetic materials have a magnetic susceptibility greater than 1. So example of this are materials that include iron, cobalt, and nickel. So these materials make the strongest magnets, and they are used singly and in combination with MRI permanent magnets. And perhaps the most common permanent magnet is one made with an alloy of aluminum, nickel, and cobalt of nickel. Yun. The next one is paramagnetic materials. So paramagnetic materials um, have magnetic susceptibility of less than 1. So this means that they are weakly influenced by an external magnetic field but do not exhibit measurable magnetic properties of their own. And such materials are platinum, oxygen, tungsten, manganese, and gadolinium. So, hindi siya masyadong na-influence ng external magnetic field. So, again, included dito ang gadolinium. So, just so you know, the contrast of that we are using in MRI is gadolinium based. So that is why if you will be asked if what magnetic property does a an MRI conscious media has, it is paramagnetic. The last uh, the last type of magnetism is diamagnetism. So diamagnetic materials have negative magnetic susceptibility, and in fact, they are slightly repelled by magnets. So such materials include mercury, silver, copper, carbon, and water. So hindi talaga totally. In fact, they are repelled pa. So, yan. Now let's discuss the laws of magnetism. The first law of magnetism is the dipoles. So unlike electricity, there is no smallest unit of magnetism. Diba? Like sa electricity, the smallest unit could be or would be electrons. But in the case of magnetism, there is no such thing. There is no smallest unit of magnetism. And each magnetic domain exists with two poles. So each magnet consists of two poles. That's why it's called dipole, kasi di means two. So it is the North Pole and the South Pole. And this dipoles, unlike electric charge, a magnet cannot exist with a single pole. So hindi pwede na north lang ang isang magnet, hindi pwede na south lang ang isang magnet. Well, in fact, if you're going to divide a magnet, it just simply creates smaller magnets. So if you have a magnet, well, some of it has labels of N and S, but if you break that, don't assume that the upper part will just be N and the lower part will just be S. But what will happen is that it will just create a smaller magnet. It will just create a smaller N and S. So yun siya. The second The second law of magnetism is attraction or repulsion. So, like magnetic poles repel, and unlike magnetic poles attract. So, in addition, by convention, the imaginary lines of the magnet's magnetic field leave the north pole of the magnet and return to the south pole. So if you're going to wonder why, how do scientists know that these imaginary lines exist? Well, they can be demonstrated by the action of iron filings near a magnet. So those scientists knew that um, magnetic field has imaginary lines by using this iron fillings near the magnet. So they placed an iron fillings near the magnet and it created a line. So again, the imaginary lines of magnetic field leave the north and return to the south. Ganyan siya. The third is magnetic induction. So magnetic induction, just as an electrostatic charge can be induced from one material to another, non-magnetic material can be made magnetic by induction. So, yun. The magnetic field lines just described are called magnetic lines of induction, and the density of lines is proportional to the intensity of the magnetic field. Ang density daw ng line na ito, um, ano siya, proportional siya sa kung gaano kalakas ang magnetic field. So what is magnetic permeability? So magnetic permeability is one of the magnetic characteristics which indicates how easily a magnetic material is magnetized. Yun. So for example, when ferromagnetic material such as a piece of soft iron is brought into the vicinity of an intense magnetic field, the lines of induction are altered by attraction to the soft iron. So, regularly, or the usual appearance of the line, diba? It exits the north and go back to the south. But if you put a ferromagnetic material near the magnetic field, so it will alter and it will be attracted by the iron. However, if a copper, which is a diamagnetic material, were to replace the soft iron, we're gonna put the copper here, there would be no such effect. Kasi nga, copper is diamagnetic. So, ang ang thought lang ng magnetic permeability is, would it affect it has, so since copper diamagnetic, it has no such effects. So magnetic force. So magnetic force is the force created by a magnetic field behaves similarly to that of electric field. So this refers to the attraction or repulsion that arises between electrically charged particles because of their motion, and it is the basic force responsible for such effects as action of electric motors and the attraction of magnets for iron. So So you could observe magnetic force if you're going to place a magnet near for electrode rectal. So kaya pa ipit yan, lagyan siya mag-attract. Yan siya. So now let's discuss the magnetic field. So Tesla or T. So Tesla or T is the SI unit for the magnetic field. So Gauss is an older unit, and 1 Tesla is equivalent to 10,000 Gauss. Now let's move on to electromagnetism. So we've already discussed electricity, magnetism. Now let's discuss the combination of the two. So electromagnetism. So a motionless electron has an electric field associated with it. An electron in motion has both an electric and magnetic field, and the interaction between the electric field and the magnetic field is the basis for electromagnetism. Okay, so let's discuss Ørsted's experiment. So Hans Christian Ørsted accidentally noted that a compass was deflected by a DC or direct current in here. So ang experiment ni Ørsted were like this. So when there's no current flowing in the circuit, yan, open ang circuit, the compass needle will point to the Earth's north pole. So neutral lang siya. But if you close the circuit like this, once the switch is closed and the current flows na, kasi nga closed na siya, so there's current, the compass immediately aligns itself perpendicularly to the current carrying wire. So it will point along with it. And reversing the current causes the south pole of the compass to point to the wire. So basically, Ørsted's observation demonstrated that a magnetic field is always associated with a moving charged particle. So the solenoid. So a solenoid is a type of electromagnet, and this is a cylindrical coil of wire acting as a magnet when carrying electric current. So this is an example of a solenoid coil of wire. So if there's a current flowing in it, it will eventually create a magnetic field. But you place an iron core inside the solenoid, it will make a more intense magnetic field, and it will now be called electromagnet. Okay, the transformer. So a transformer incorporates hundreds of loops of wire coiled on a ferromagnetic core, and the core concentrates and intensifies the magnetic field. Because of a moving magnetic field is required, a transformer will not work on DC, but only on AC or alternating current. Now let's discuss the RF coil. RF coil, or also known as the radio frequency coils, are the receivers and sometimes also the transmitters of radio frequency signals in equipment used in magnetic resonance imaging, or MRI. So the MR signal is produced by the process of resonance, which is the result of radio frequency coils. So the oscillating electrons in transmitting antenna or the coil produces RF, which in turn induces a signal in the receiving antenna or coil, and this is similar to the way that the net magnetization in the patient interacts with the RF coils in MRI. Okay, So that ends my lecture. And for your reference, or if you want to read the whole chapter, you may check out the chapter 2 of Stuart Carlyle Bushong's fourth edition of Magnetic Resonance Imaging book. That would be all. Thank you.